we're going to take some risks here. First of all, I'm going to talk a little bit about preparing data for ML. And what that means is I'm actually not going to talk, I think it's not going to be until slide 26 that I mention parameters. And I'm not going to mention like perplexity or dimensionality at all. We're just going to talk about data for a little while. This is me. I used to work at Google. Before that, I worked at AWS. Now I work at Databricks. As my wife says, keep trying, Craig, and maybe eventually you'll be satisfied with the products you build. It's all about the data. Hence the reason why I want to talk about the data up here for a minute. I would argue that for the next few minutes, as I said, I'm going to take a risk. And the reason I'm going to take a risk is that usually I find myself spending time talking to CMOs and COOs or whoever about their LLM strategy, and I actually can't talk to them too deeply about it because they gloss over and they have no idea what I'm saying. Today, I'm in a room of people who care about this stuff and who are focused on this stuff, which is extraordinarily exciting. And so instead of taking it super deep, I'm going to try the ninja move. And the ninja move would be, I'm going to try and simplify this to such an extreme that only experts could understand the simplification. We'll see how we do. First of all, I want to start out with this. At Databricks, we're a huge fan of data. And we are particularly a fan of companies that obsess about how to build an extraordinarily strong customer experience for new types of data. And at Pinecone, Ido and the team, this is what they've been working on, and it's extraordinarily exciting. I got to work with Ido on SageMaker. He, at the time when he was starting Pinecone, it was, we were all a bit confused about what he was chasing a couple of years ago when he was telling us that vectors and embeddings are about what the future will be about. And then sure enough, I think earlier this year, it became clear that dedicating a team ahead of the crushing demand means that you can have a product this strong at this moment, right? It's extraordinary. So let's dive into this. How can I compete in an AI world, right? Everything is changing. The pace of innovation has gone off the rocker over the last couple of months, right? All of a sudden, modeling techniques are quickly being commoditized. New models are coming. Google is telling us they have no moat. It's insane, right? Your data is your competitive advantage. And this is something we've been saying since machine learning was showing up, right? Since very early on in machine learning. Let's forget about LLMs for a second. Let's just talk very early on in machine learning. What we would do is we would go and meet with companies and we would say, hey, what data do you have that could be particularly interesting for helping you predict something? And then last year, OpenAI launched ChatGPT, and we all said, data, forget it. Let's just go after these large language models. But as it turns out, if you do that, all you're doing is using the same tool that your competitor is using. You're using not only the same tool, you're using the same model that your competitor is using. There is no differentiation other than your prompt at that point. Maybe some of the context you hand in. Now, given that it's about the data, handing in that context or building that model of your own are the ways in which you can build that kind of, next gen or that next step of differentiation. So generative AI has been exploding on Databricks. We have 1,500 companies have trained transformers over the last 30 days. We're seeing a 25% month-over-month growth of GPU usage, which if for any of you, I'm sure there are some folks in here who would like to use GPUs. I'm sure you can probably have some empathy, and we have empathy vice right back at you for how miserable the situation is trying to get GPUs, other than maybe on Oracle. Having said all of this, I believe that the current AI platforms that we're asking you to use to build models are broken. And the reason they're broken is because they're standalone, right? They're built as these, I am the AI platform, and I have all these capabilities inside it, but I'm not actually connected to any of the outside capabilities. I'm not connected to the analytics stack or the data stack or the production stack. You have to take care of all those connections. That's broken, right? What that means is that ultimately, your practitioners have to go find people who have different skill sets to help them connect to all these other systems, right? And so this is why at Databricks, we've started talking about this idea of Lakehouse AI. And Lakehouse AI is really simple. It creates common tooling across your entire data layer, end-to-end governance, end-to-end lineage, version control, single copy of your data, right? Models can inherit the governance of the data they're trained on, right? All of this is what machine learning ought to look like and what AI ought to look like. But it doesn't. And so we think that needs to change. And by the way, you're going to hear me talk a lot about machine learning, and you're going to hear me talk a lot about data. This is the thing I can't say to the CEOs and CMOs and CIOs, is that at the end of the day, the workflow in these applications or in these large language models, it's the same workflow, right? It's the same workflow that we've been using for a decade to build just classic predictive models, right? It's just that now we have a couple new nouns, we have a couple new verbs, we have a new data store, right? We have a couple new pieces that have been put in, but the general activities and actions we're asking of you are the same. Now, before I get further, I'm going to end up talking about this thing called the Unity Catalog, and I'm going to talk about it because really I can't not talk about it when I'm talking about AI, Databricks, and preparing your data. The Unity Catalog is a central catalog for kind of orchestrating, managing, and controlling, governing all of your data in your data lake. And it's a special kind of catalog because it's not a pain in the neck. And what I mean by that is when you go build new data artifacts, you don't have to go and register them and enter a bunch of metadata about them and all of these kinds of things. It just does it automatically, right? If you transform this data set, boom, we know, we can show you in the lineage how that data set's been transformed, right? It doesn't have to be this kind of, miserable experience that you have to go out and orchestrate with this other system. It can just work. Now, why does that matter? Why is that important? Because this is the difference between doing AI in a data-connected system. And I'll tell you, a lot of this is boring. And the reason it's boring is because I told you already that I wasn't going to talk about parameters, and I've already mentioned governance like 4 times, right? But at the end of the day, having this capability, not only does it please everybody in your company, not only will it protect you next year when the EU AI Act comes, but also you'll build better models, right? And so let's talk a little bit about that. Meanwhile, putting my phone over here so that I can watch the clock. All right, so this is what I think a machine learning workflow looks like. I had somebody who told me that this was far too simplified, and I said, yeah, the problem is if I put something much more complex on the slide, nobody will pay attention to it. So this is what I'm going to use, right? Basically 3 things: data sets, models, and applications, right? Now, models are born from data, right? And let's be honest, they should be a bit more respectful about that, right? We have invested tremendously so that, in your company, your data has lineage, it has governance, it has all these rules and systems and ways in which it's protected, right? Ways in which others outside your company can't get into it, or ways in which people in your company who aren't supposed to get into it can't get into it, right? And maybe, if you're lucky, you have a system of lineage on that where you could look at a data asset and say, where did this come from? How did this get made, right? These 2 ideas, while they've been central with data, are completely foreign and absent in AI. Now, I shouldn't say they're foreign and absent. If you use MLflow, if you use weights and biases, if you use some of these other tools, they'll keep track of what you're doing, but they'll keep track of what you're doing across your machine learning and AI context, not across your data plus AI context. And that makes a huge difference. So challenges with ML data, right? I need to be able to discover this data. I need to be able to serve this data, right? I need to be able to support complex calculations and functions and transformations with this data. I need to be able to chunk this data. I need to be able to tokenize this data. I need to be able to embed this data, right? All these different things you can do with data. Now, I will say, if you're trying to, do massive chunking of data or massive tokenization of data, Spark is not a bad way to do it. Now, having said all of that, these challenges or these activities we have to do, they create problems for us, right? If I want to go use one of the cloud's AI platforms, the first thing I do is I go to my data and I build myself a training set. And then I take that training set and I move it over to my blob store, and then my AI platform sucks it in out of my blob store. What's the problem with that? That sounds great. It's actually a super rational way of thinking, right? Because what does it do? It maximizes your TAM, because now anyone can use your system, because anyone can write to S3, right? The problem is that export of data, that moment when I took the data out of its system of record and put it over here in Blob Store, I broke all connections with the past, right? I no longer know where this data came from, which means that when I build this model, I have no idea where this model came from. Or when I run these inferences on this data, or when I run this generative AI on this data, I have no idea what it's connected to. So with the Unity catalog, we keep track all of this for you, right? We keep track of it all. We show you what your data look like. We show, if all of a sudden you're looking at a piece of data and you want to see where it came from, you can just walk up that lineage chain and take a look and see where it came from. Maybe you'll see that data has a different structure or looks differently. Or, hey, you'll find out that this little tiny snippet that you have, or this little small chunk you have, you'll be able to understand it as part of a larger story, right? You'll have an increased kind of contextual understanding of what it is you're looking at, right? Now, as part of this, at Databricks, we've made it easier to serve this data directly to models, right? So if you're having to serve any type of data to a model, right, you need to do it low latency, you need to be able to, match it to the primary key and all of these kinds of things. We will do all of that for you, all of that automatically. Now, what about my vectors? So Pinecone and Databricks, there's the QR code. Yep, take your phones out. Come on, if you're going to take a picture of any of my slides, at least take a picture of the one with the QR code. By the way, quick pause. Huge thank you to the two of you who reached out on LinkedIn earlier today and told me what a great job I did in my presentation. I massively appreciate. Without that, I don't know that I would have the confidence up here that I've got. So huge thank you to you guys. No, but if you go to this page, this document, we have not only do we have a partnership with Pinecone, but we have docs, right? I mean, that tells you how far down we are now, or how far through this we already are. Now, with this, you can go there and you'll quickly and easily see how you quickly upload your data into Databricks, right? How you can quickly kind of tokenize and create your embeddings, right? And then how you can upsert those embeddings directly into Pinecone from Databricks, right? So, nice and easy. You can see the Git repo there as well. You can use the Pinecone Spark connector to take care of all of that for you. Now, we've talked a little bit about data. We've talked about the importance of data being fully governed, right? And we've talked about the importance of data and lineage, right? We've talked about tracking that lineage, and then we've talked about this strong position of Pinecone within the Databricks ecosystem. Now, let's talk a little bit more about models. So, at Databricks, we support all of the classic all of the classic SaaS APIs. If you want to come use, OpenAI or BART or MPT or Anthropic or Cohere or something like that, those are all super easy to access. We have actually made it so that you can use SQL to access them if you want to, right? If you have a table of text snippets and you want to, get the summary of each of them or the sentiment of each of them, or you want to extract information from them, you can do all that super easily directly in SQL, right? What I'm really telling you is that the people who bother you about going and doing some work for them, you can just say to them, hey, go write your own SQL query, right? So we also have made it really easy by taking a series of open source models and kind of massively optimizing them for usage on Databricks. Now, this moment, from the SaaS models over to the open source, I believe that we're already seeing open source starting to catch up, not with GPT-4 per se, right? GPT-4 remarkable, 3.5 remarkable, but I would argue that very few companies care about what the economic policies of the 9th president of the United States were. It's interesting, yes, but probably not important in an enterprise or business context, right? And so how can we help you, not with massive models that can help you answer any question, or as my son likes to do, write any number of random poems and what have you in the style of Hamilton. But, as you think about trying to solve the problems in your business, having these models be narrower, having them be smaller, and having them be more dedicated to your area of domain, right? Or maybe even your particular task, right? We believe that not only will you probably get better results there, but that you'll probably do it at a much lower cost, right? When we've been building capabilities for our users of Databricks to have a more kind of generative experience, we use OpenAI at times, and we find ourselves passing giant prompts, right? Now, the problem with giant prompts is that they take a lot of time and they cost a lot of money. Whereas if I have a much smaller model that is more portable and doesn't need such a large prompt because it already has my context, then all of a sudden I'm off to the races and can do a whole new series of capabilities. So we have these models on here so that you can much more easily serve them as well as fine-tune them to your needs and to your problem. Now, building your own generative AI, this is a very exciting moment for me. Some of you may have heard of a company called Mosaic ML. They're the creators of the MPT series of models, so MPT 7B. Databricks recently announced our plan to acquire Mosaic, and for the first time, I'm getting to show Mosaic slides, hence the reason it's a white background. I apologize. So I talked a little bit just a moment ago about the importance of smaller models, right? These large language models don't have to cost a fortune, right? We all live in a world that says, hey, your job is to create prompts, and your job is to maybe fine-tune, but that's it, right? I would argue that that's not the case. I would argue that for $6,000, you could train a 3 billion parameter model, right? For $30,000, you could train a 7 billion parameter model. I said that I'd wait till slide 26 for parameters. Here we are, just so you know. These are costs that, first of all, are far lower than anyone could have imagined and far lower than I think the popular press would have us believe, right? Oh, it's going to cost billions of dollars to create one of these models. No. Few thousand, maybe a couple tens of thousands, and you can have a really, really powerful model dedicated, again, to your context. Now, what about comparing models? What about understanding which model is better? There's a gentleman in the audience whose whole business is about this, which kudos. I look forward to buying stuff from you someday. This is an area what we're working on as well. And we want to make sure that MLflow maintains its position as the number one library, or open source library for MLOps. And we want to make sure that it can extend that not just to MLOps, but to LLMOps. And so we're building MLflow evaluation, which allows you to evaluate models and prompts directly in ML Flow, right? So you no longer have to kind of do this on the side, right? Our expectation is that over the next 24 months, if you're building LLM and generative AI applications today, I hate to say this, and I promise I won't tell, the folks you work for this, but my guess is you're going to swap the back end out of that thing probably at least 3 times in the next 2 years, right? This space is moving so fast, right? The quality and the cost, is increasing so quickly and the cost is decreasing so quickly that whatever you build in Q3 of 2023 is probably going to look pretty silly in Q3 of 2024. And so we want to make that really easy to cope with, right? We want to make it so that you can compare these things really easily. And we're also building the ML Flow AI Gateway. And the idea of the ML Flow AI Gateway is actually to do just this, is to build you a layer under which you can swap out your LLMs beneath the sheets. And, if you're switching that back end, you can swap out that back end without your higher level application even knowing that you did it, right? You can control your credentials management, right? If you have a bunch of different people in your company who are all using OpenAI or something like that, great. And I should say, I said OpenAI, but Craig, OpenAI can't be wrapped in ML Flow. Aha! You can now wrap SaaS APIs in ML Flow as well and see them as models in your model registry. So you go to your model registry, you grab ChatGPT, and you can quickly and easily control. You log every request, cache all those requests, but then control rates and access and cost controls and what have you for these models, right? All directly within ML Flow. So, as I said, data sets, we want to make sure you're fully governed, right? We want to make sure you're fully aware of your lineage. We want to make sure you're ready. If you work in a regulated industry, we want to make sure you can meet those regulations. And if you don't work in a regulated industry, the EU is about to make you feel like you do, so not to worry. And so these kinds of things are going to end up being extraordinarily critical. Now we've also talked about models at this point, and how both SaaS and open source models can be managed in ML Flow, how they can be compared, how you can train your own one of these models, right? These are the opportunities available to you when it's your data, right? When you're not just depending on a separate organization to go build a model that you're just going to use without having attempted to bring it to your specific company's context or your specific task's problem space. So let's talk lastly a little bit about serving. Model serving optimized for large language models. So, strong GPU presence available. And then not only GPUs available for model serving, but also these models like the MPT series and the Falcon series, right? Highly optimized to run, we think, at least half the cost that they would run if you just dropped them on a GPU all on your own kind of thing, right? So, and not only that, but also monitoring. Right? Monitoring to keep track of all of this. Now, monitoring is my favorite part of AI and ML at Databricks. And it wasn't before I joined Databricks. At Google, I didn't pay a lot of attention to monitoring, in part because we didn't have a product that did it very well. But the second part of the reason why I didn't pay attention to it is because we couldn't do, we could tell you your skew, we could tell you your drift. We could tell you your SHAP values, right? We could maybe, log your responses. But when your AI platform is connected to your data layer, you can do something entirely different when you start monitoring. And what I mean by that is you can imagine that, just to simplify the situation, let's say we have a basic machine learning model, and it's got 10 features in that model. Let's say that model starts drifting, right? If I use a classic monitoring platform, it's going to say, hey, your model's drifting. We're not. We see that model drifting. We're going to go, huh, the model's drifting. Let's go look at the features. Because we know the features. Not only do we know what the features are, but we know where they are. And not only do we know where they are, we know their entire lineage history. So we're going to go look at your features and say, whoa, hey, feature number 4. This table, this doesn't look at all like it did yesterday. Oh, look, the load job didn't run. Hey, so this problem you have, it's probably feature 4 that caused that problem. That's pretty cool. But that's not where it stops, because that lineage, we think of lineage as something that goes backwards, right? I can see where this came from. But lineage also goes forwards. So as I see that feature that's misbehaving, I can sit there and immediately see that not only is it in my model, it's in these other 2 models too, and it feeds this table over here in this transform job. And to be honest, it's in a dashboard that one of my executives just looked at, right? All of that is available to me when I have an AI platform that's intimately connected or natively connected to the data layer, right? And these are the ways that, machine learning and AI ought to behave as we get to this point where finally it's kind of meeting all of our expectations. As someone who's been working in this space for years, you go into organizations, or you go into, or you talk to my mom, and they say, hey, this machine learning stuff sounds cool, sounds complex. Does it do anything important? Now I don't have to have that conversation anymore, as I'm sure none of you do either. Everybody understands the importance. It does ChatGPT, right? But this boring stuff, this governance, this lineage, this monitoring, these are the things that make it so that we can not only have a quality model, we can do it in a way that is understandable, defensible, explainable, potentially, right? We can be much more responsible in the way in which we have put together and deployed this model. And then, as I showed with monitoring, we can just be smarter about the way we react to all of this. Sorry if I just sprayed you in the eye with the purple or with the green laser. I was trying to advance the slide. But so we've talked a little bit about data sets. We've talked a little bit about models, and we've talked a little bit about serving and monitoring that serving. If you're going to build ML and AI, do it in a fully governed way that takes advantage of your data's intelligence, right? We didn't even really talk about that, but as it turns out, if you're using data to build something and you have a data platform that has a full understanding of your schema, you can actually discover proximal data way more interesting and in a way more interesting and exciting way than if you're just spearfishing in your own data warehouse, right? LLMs are the most transformational tech of the time. I got in some trouble when I was speaking at a large bank, and I told them that I thought that the internet was just the training data set for LLMs, and that 5-10 years from now, we're just going to look back at the internet and say like, we did a good job putting that training set together, right? As we build out this next phase of technological innovation. Pinecone is the leading vector stack. We are in awe of what Pinecone has done. It's amazing. Go and open one of the open source packages that does this, right? Or one of the open source packages that has bolted this onto the side in the last 6 months. If you really want to see the power of Pinecone, go do that, right? Because you'll quickly and easily see why Pinecone is the company to use in this space and why it is we've partnered so deeply with them, right? We're excited to continue to partner with them, and hopefully we'll continue to partner with them more deeply over time. We hope to have more announcements in the future about increased compatibility between Pinecone and Databricks. And I think one of the things, there was a great, early on, probably, January, we were sitting in a meeting at Databricks, and Ali Godsi, our CEO, said, I want to sell the picks and shovels for this LLM rush that's taking place. We all say, oh yeah, okay, that makes sense. That's better than trying, that we'll go for it. We'll sell the picks and shovels. Yesterday, I saw a cartoon of a little stand selling shovels, and it was labeled NVIDIA, and a bunch of folks walking away labeled data scientists, right, with NVIDIA branded shovels. Certainly NVIDIA is one of the sellers of shovels. We like to think that maybe we're one of the sellers of shovels, and I think we can all agree that without Pinecone, we would all be in a much, much worse place in this technological transformation that we're going through. So with that, I will say a huge thank you to all of you. Unfortunately, I don't have time for questions, but I will be around if anyone has questions and wants to geek out on this stuff. Thank you very much.